on my computer. All right, so to get started, I'm going to share my screen so you can follow along with the PowerPoint that we have. Okay, so this is the composite materials merit badge. Let's see. So number one on your workbook, the first requirement is to explain most likely hazards you may encounter and what you should anticipate, mitigate, and prevent, and how to respond to these hazards. Also, at the other box said to describe the appropriate safety gear and clothing that should be used when working with composite materials. So the general safety rules, you know, your personal safety rules, obviously you want to avoid inhaling, okay? Always wear a respirator and a dust mask if the manufacturer recommends one, obviously. We'll talk about that. And then you want to avoid skin contact. You never want to, we'll always have gloves on. We'll always have non-absorbent protective clothes. We'll always be wearing gloves when you're working with composite materials. You always want to wear protective eyewear with side shields. So basically it's goggles, you know, that have the side coverings so that none of the material gets splashed into your eyes. For fire safety, we definitely want to avoid open flames. We'll never be working around an open flame. We want to keep flammable solvents in a closed container. Keep a fire extinguisher close by. That's always a good thing to do. Clean up the work area immediately, and you'll see why on Saturday, because it truly is messy and it smells. You want to permit the excess resin to occur. It means it's going to get hard and it's going to cool before we throw it away. Okay. For environmental awareness, which is what it talks about on page 2 at the top in that box, the precautions that be taken, you want to properly dispose of the waste material according to the manufacturer's recommendations. And we'll show you how to get those recommendations. You obviously always want to label the containers. For safety and environmental awareness, we're always working under a qualified supervision, okay? We always work in a well-ventilated area. In our case, we're gonna be outdoors, and that's the best place to be when you're working with composites. You're gonna know the hazards of the compounds that you're working with by looking at the MSDS sheet, which is a material safety data sheet, and we're gonna talk about those in a little bit. Which is right now. So the MSDS sheet. Now this is a sheet that every time you buy a chemical, especially one that's in a bottle or a composite material or a resin, which we'll talk about, there will be a MSDS sheet that usually either if it doesn't come with it, which it usually does, but if it doesn't, you can find them online. Those sheets will give you the proper procedures for working with that material, for how to handle it and how to store it, okay? It also alerts everyone to any hazard that could come about, like a fire hazard. If there's a certain temperature it has to stick within, if there's a, you know, like if you shouldn't put it in a closed container, like a file cabinet, there's gonna be all that information in that sheet of paper, okay? There's 16 sections under that standard that they use to fill out these MSDS sheets. And those will talk, and under those standards, there's going to be, they're going to identify the substance identity and the company contact information. So wherever that chemical was produced, that company's information is going to be in that sheet. The chemical composition and the data on each of those components is in that sheet. Hazards identification, you know, anything, a fire hazard, freezing, you know, anything. Your personal hazard, what to do if you get it on your skin. All of that stuff is in that sheet. Like the first aid measures. You get it in your eyes, never ever want to do. It'll tell you how to take care of it. Firefighting measures. Sometimes on a composite, you never want to put water on it, or sometimes you do. All of that information is in that MSDS sheet. And accidental release measures, meaning if you get it into the environment, like if you disposed of it and it accidentally spilled into a drain. Oh no, what can we do about it? We're going to go to the MSDS sheet to find out. Okay? So, any questions so far?
I have a flash.
You have a what?
A flash.
Ranger Anthony has a question.
Flash. MSDS sheets, material safety data sheets. Okay, remember that name, because as you get into the job market or into outside your when you grow up, let's say, MSDS sheets are under a right to know rule. Okay, so in other words, you as a public, you as a person have the right to know. So anytime you work around chemicals, like let's say you came up to Camp Trask or you are going to Firestone and you're going to be working with these chemicals, we have to have MSDS sheets posted or close by. So again, if you were to go to the supermarket, even though you don't see it, all the food there, right behind those closed doors that you never go, or sometimes you do go in the bathrooms in the back where all the extra food and stuff are, is a rack with the MSDS sheets on them. That's because the employees have the right to know what they're working around. So MSDS sheets are very important. They're all around, even in your home. Did you know the chemicals that you use to clean, the soaps you use, have MSDS sheets? Everything down to a bar of soap, everything down to Clorox bleach has an MSDS sheet. Where do you get those? Because they don't come with what you buy them. You go online and that's where you can find them. The flash is over.
And like he said, you could always Google MSDS sheet for the laundry detergent that your parents use to wash your clothes. There's an MSDS sheet for that as well. Everything that has chemicals has one. Okay, moving on. Number 2, at the bottom of page 2 of your workbook, you're to explain what are composite materials. Okay, so on the screen here, you can see that composites are engineered materials made from 2 or more constituent materials with significantly different physical or chemical properties. And they remain separate and distinct on a macroscopic level within the finished structure. Now, if any of you have taken chemistry in school, or if you haven't yet, you will eventually. That's a really an interesting class to take. You've got biology and you got chemistry. Well, biology is the study of living things. Well, chemistry, you're studying chemicals and the components of it. You know, when you mix 2 chemicals together, what do they make? All of that stuff. A composite is 2 or more put together, but they still remain separate. And you'll see that when you make your composite project on Saturday. You're going to see how when we put 2 significantly different materials together, what they form. Okay, so that's the definition. The history of composites, which is on the top of page 3 in your workbook. Now, the history. The most primitive composite materials were in biblical times. So back in the Bible times, they used to take straw and mud, and they'd mix them together, and they'd form bricks. And they would build their homes or any other kind of construction they were trying to make. Okay, in the book of Exodus, it speaks of those Israelites. They were forced to make bricks without straw. They were oppressed by the Pharaoh, and that one's really interesting, how they did it. You know, I'm not gonna get into that. The Mongol warriors, they used bows, and they made them out of several layers of bamboo that they held together with silk. And they sealed it with pine resin. So they made, you know, composites have been around for much longer than we have. Okay, steel and rock. They reinforce concrete, plywood, and asphalt. Those are also composites. Actually, here you see on the screen in 1907, Rolls-Royce made their gear shift knobs out of a composite. It was a synthetic resin called bakelite and cellulose, which obviously comes from a plant, right? And it was also used for oven-safe kitchen pan handles, so that moms, you know, and dads that bake, they actually made the handles out of this, so you could actually bake them with the handles on them. A lot of times you can't do it because they're plastic, right? Well, this kind of composite you can. It was actually the first synthetic resin filler composite. All right, so today though, composites refers to materials made with reinforcing fiber with a synthetic resin, which is what we will be doing on Saturday. There's several different reinforcing fibers. Most of you probably heard of fiberglass. You know, the arrows, if you've done archery before, some of them are made out of fiberglass. That's why you gotta be really careful touching them. It gets those little flecks in your fingers and it hurts. You know, carbon graphite, we'll talk about those. Kevlar, you know, the police bulletproof vest, or helmets for motorcycles. Resins are typically unsaturated polyester or epoxy. The non-isotropic or directional nature of the fibers in the resin can be controlled. Okay, that's today. Examples of composite applications. There's so many, like Ranger Anthony was telling you, there's so many composites in your home, outside your home, that you probably didn't realize. Boats, if you have a watercraft of any kind, it's made out of composite. Airplanes, you've seen the B-2 bombers fly overhead on New Year's. Those are made out of composites. You've got your tub and your shower. If you've ever seen a tub or a shower broken in pieces, there's like little fibers on the bottom, okay? That's because it's a composite. It's got your fibers and your resin, and they've made a composite. Your snowboard, if any of you have a snowboard, skateboards, you know, those are all made out of composite. If you play tennis, your tennis racket is made of a composite, okay? There's many car parts, you know, the Corvette, the leaf springs, you know, when you put the leaves on. Your circuit boards and computer housing, like Ranger Anthony said, the shell of your laptop or your computer is a composite. Your truck cabs, you know, if your dad or, you know, another parent has a pickup truck, the cab of the pickup is made out of a composite. And there's several examples there on the screen that you can see, different types of composites, and just everyday things that a lot of us don't know we're actually looking at a composite. You can see the layers there of the skateboard or snowboard there. There's several different layers. You've got your fiberglass, your resin, your sidewalls. It's really interesting. I don't suggest you going and taking a skateboard and cutting it in half, but there's your B-2 bomber example. Your joint strike fighters, those are made out of composites. Several more applications here for examples, if you want to list them. Your utility poles outside, you know, like I said, satellites. If you have a satellite for your cable, it's made out of a composite. A lot of sports equipment. The pool, if you have a pool that has a you know, certain indoor pool, above ground pools for sure, a lot of them are made out of composite. Some tables and benches, fishing poles, which is really interesting. So for 2B on the lower half of page 3, you're supposed to compare the similarities and differences between composites and wood with aluminum, copper, and steel, which you can see across the screen here. There's several, you've got aluminum, copper, steel, wood, and composite, or fiberglass. Here, so the physical properties are the first row across. So the physical property of aluminum is moderately hard with moderate strength and stiffness. Copper is moderately hard with moderate strength and ductile though. So all across here, you can see the different physical properties. So in your workbook, it's on page 3 and 4 and 5 and 6 and 7 and 8. Yeah, 3 through 8 is all of this information that's on the screen here. It talks about your physical properties, electrical properties, mechanical properties, corrosive properties, the flammability. We've got your cost and other properties, like down here at the bottom, you can see if it's easily recycled or if it's renewable, or composites, unfortunately, are difficult to recycle. Okay. Now for this one, does anybody need this information for their table? Raise your hand. Okay, so what I'm recording this, so what I'm gonna do is when it's all done, when it uploads, I will send it to you so you can fill in your workbook. So don't stress over that right now. Okay, now for the rest of this PowerPoint, it's gonna talk about the different, like on page 9, you're supposed to pick 3 different composite reinforcement materials. Here though, it's talking about the ratio of strength to weight. Steel is strong, obviously. Aluminum is a little bit stronger. Glass fiber, you got even more. Aramid there is really strong. Carbon fiber, definitely. That's why most really good motorcycle helmets are made out of carbon fiber. You would prefer, if you had a choice, get one made out of carbon fiber, because you know your head's obviously the most important part of your body when you're riding a motorcycle, and you want to protect it as well as you can. So that's really important. Reinforcements here on page 9 of your workbook, it's got here, this is page 9. They carry the load of the project you're making. Okay, so the reinforcements are carrying the load and they give it the strength. Okay, there's different kinds here. There's glass, you're supposed to write down 3 of them. There's several different ones here. You got glass fiber, the carbon and graphite fiber. Those two, like it says here on the slide, those two terms are often used interchangeably. So if you have carbon fiber or graphite fiber, they're usually talking about the same kind. The aramid fiber and then the hybrid composites, which are a combination of more than one. They can come on a spool like thread, or they can be woven as a cloth, or they can be random fiber mesh. Okay, and the fibers can vary in size depending on the characteristic needed. Okay, so for page 9, glass fiber could be number 1 that you have here. Positive characteristics are the least expensive of all the reinforcements. So that's definitely positive. A negative characteristic, what's a negative characteristic of fiberglass?
Characteristics of fiberglass.
You're supposed to know a positive characteristic, a negative characteristic, uses, toxicity, disposal, and safe handling.
A negative characteristic of fiberglass is it's very hard to work with. It's cheap, positive. It's very hard to work with, and it's very abrasive.
Okay, so Ranger Anthony said one of the negative characteristics would be that it's hard to work with.
Disposal.
Okay.
Disposal.
And it's hard to get rid of.
You can't
So you can't just throw it away. Okay, it's really hard to dispose of. It is used in 90% of all composite applications. And that's why in the page we showed about the differences, composites are really hard to recycle because it's hard to dispose of. And if we don't have the information on here, don't stress about it. If you find it in the book, even better. Okay, so that's one of them. The carbon graphite fibers here, they're super strong compared to glass fibers, obviously. They're extremely stiff. That's why they're the strongest. They are lighter than glass fibers. One of the negative characteristics is they're very expensive. They are used in aircraft structural parts, your golf club shaft, your tennis rackets, your bicycle. That's another one that's made out of carbon fiber. I'm sorry, yeah, carbon fiber. Your bicycle frames. That's why they're really strong. You can flip over the handlebars and hurt yourself. And sometimes your bike's perfectly fine. Okay, so that's another one. The Aramid Fibers. And here you have your Kevlar and your Nomex. That's why I said the bulletproof vest. Okay, they are DuPont trademarked Kevlar Nomex. They are impact resistant. Okay, the cost is between the glass and carbon, so they're kind of mid-cost, mid-range between. They are more difficult to work with and cut because it's so strong. They tend to absorb moisture, and they definitely are used extensively in body armor and cockpit doors on the airplanes, so that, you know, the pilots are safe from any kind of hijacking. Okay, your hybrid composites, you only had to list 3, but this is the 4th one. They use 2 or more different reinforcements, and the reason they do it is to provide specific properties that maybe one of the reinforcements didn't have enough of what they needed, so they put 2 together. Okay, so that was your composite. On page 10 of your workbook, you're supposed to talk about 3 different resins. Okay, so there's different resins that we have here. Resins are, you know, polymers, the plastics, and they hold the reinforcement and composite together. So you'll be working with resins for sure. They smell a lot. They protect the fibers from the environment, and they transfer the load. So it's stronger that way. There's Thermoset resins that chemically react at room temperatures. Okay, they solidify at a, you know, normal temperature. The thermoplastic resin, they melt or soften at elevated temperatures. Okay, so higher temperatures. And then here your thermoset resins are, they change from liquid to solid in an irreversible process. Okay, so you're gonna go from a liquid, when you pour it, it's gonna solidify and make a solid, but you can't take it back to the liquid. Okay, it's an irreversible process. Okay, they're set. Thermoset resins cannot be recycled once you cure them. So once they become hard, once they leave the container and they get hard, you're done with, you know, you use it and then you have to throw it away. You can't recycle it. Polyester, Phenolic, Epoxy, and some others are different kinds. Okay, your polyester thermoset resins are the most common. They are low cost, they're solvent resistant, and they're easy to use. Okay, your phenolic thermoset resins, they are the oldest one. They're very brittle, non-conductive, definitely flame retardant, so that's a good thing. They're inexpensive. They generate steam. So this is one thing that when you are creating your composite, if you're using these, they're gonna generate steam as they get hard. So it's really like, oh no, what's going on? It's normal for them to generate steam. Okay? Your epoxy thermoset resins, they're very tough. They're chemically resistant. They degrade in the sunlight, unfortunately. Very expensive, and they're hard to produce. Thermoplastic resins. Now these are solid resins, but they can be melted and molded, and then you can remelt them and mold them again. So thermoplastics are awesome. So you can, basically, they can be recycled because it's like soda cans, you know, aluminum cans. You can recycle it, and then the recycle company is going to melt it down and make new ones. Just like a thermoplastic resin, you can make something, then you can melt it and make another thing. And there's several different kinds down there. You got PET, PE, PP, PVCs, all those kind of, which PVC is very common, the polyvinyl chloride. Now, sandwich panels and things like that. He's going to get into some more information about making composite. I asked Resir Anthony to talk about some of these. You're going to see what you have on the screen here, the sandwich panel with your like honeycomb thing there. We're actually going to show you some of that stuff, a sandwich construction. And does anybody have a surfboard? If you have a surfboard, they're actually made out of a sandwich construction. And hold on a second, my computer just went to my phone. Hold on. So sandwich construction, Mr. Anthony will talk about that and some of the others.
So, hey, how's it going? Hope you're getting a lot of information and it's like sticking, right? No, you'll forget most of it, but as you get to do some of it and see different things, then it'll click, right? So, Miss Andrea talked about a surfboard. Actually, a surfboard is used with a blank, okay? Blank could be a styrofoam or something like that, and the process of a wet layup is what's used on a surfboard. So in other words, that's taking the fiberglass, laying it over the blank or the styrofoam, and then laying the fiberglass over, and then putting the resin on top. And over several processes, then that begins to take shape. And it's kind of a smooth thing. You just got to be really careful with it. So again, because you don't want no bumps or air bubbles. It's like kind of like painting a car. They're doing something like that. So sandwiching is a different process, and most of your sandwiching occurs for flooring or where they want structure. So the sandwiching has an inner layer, which is usually called a honeycomb. And then what they do is they put a layer of, again, a wet layup piece over that and put the honeycomb in between. And then through compression and injection, it pushes together, making a hard, firm piece of, really thin piece of composite. And where might they use that in? If you said airplane floors, that's where a lot of it is used. So they'll use that on the floors of airplane. When you're walking, you're usually walking on a sandwich piece of a composite. Now they come in different types. Some may have cardboard in between them. Others may have, and when I say cardboard, it's a specially designed cardboard. Some are aluminum, and the aluminum, it gives even more strength, and it's light and it's easy to work with. So there's open and closed molding. Okay, I'm going to go over that real quick. Where we at? Oh, we just talked about that. Okay. Yeah. Okay, open and closed molding. The resin and reinforcements are laid into the mold and allowed to sit there while exposed to the atmosphere. And then again, like I said in the surfboard thing, it's a wet layup. You put that on and you form it and you shape it. And a lot of boats are made that way with a wet layup process in an open mold. Now, closed mold, I don't know that they have many of those examples, but it used to be where you went to the zoo and they had this machine with a mold, and when you put in your, like, well, back in that day it was 50 cents, you know, but the mold would close and then wax would be shot into the mold. At the same time, air was being pushed in. And as air pushed in, it pushed all the plastic to form whatever, the elephant or whatever you were getting out of the little vending machine. So again, the same thing works with, let's say, a kayak, okay? Two pieces come together and they lay some some resin in there. Well, a lot of kayaks are really plastic beads. There's a lot of plastic beads, but this is a really good example. When those two molds come together air, it's heated up, and then air is shot in there, pushing that out to make the mold of the kayak. So open mold, less expensive, less equipment involved, and includes hand layup, small parts, which we're going to be doing. The spray, large bolt haul, again, it can be sprayed on. Casting, we talked about that. And going a little fast there. Okay. Equipment, good for, this is closed mold again. Equipment, and good for automation and high volume. Includes compression molding, resin transfer, vacuum bag molding. So again, there's that vacuum process I was telling you about. But these are really cool pictures, okay? So they're spraying on the spray gun and shooting it in there and laying up. They have special tools. Now you can see why you would need special kind of respirators. One thing I don't know that she mentioned, you know, and we'll have the regular dust mask for you, but that is really not the proper mask when working with resins constantly. That doesn't protect you. If you know what microns are, the dust is a little heavier particle. So a white dust mask, you know, will filter out dust. But when it comes to vapors, then you're usually wearing a cartridge filter. We're not going to use those because we're not working around it for a long time and we're in a well-ventilated area. So, filament winding, there's all kinds of different processes. It's in your book. We can be here all night talking about these, but injection molding, again, I mentioned the vacuum where you put two pieces together, a vacuum sucks it out, spreads it out, and then it hardens up before, you know, it sets up before it, then it's removed. Next slide. Male mold, female mold, there's more of the molding process. Next slide. Okay. Vacuum infusion. Okay. So vacuum infusion is something I know very little about, but again, you can see how it is in the old mold, you know, the mold, closed mold process. Next. Okay. Resin transfer molding. No, this is the same thing. Okay. It's injected, resin's shot in, vented out, boom, you know. Winding. You have pipes. Okay. Interesting. She had mentioned telephone poles earlier. If you ever saw a composite telephone pole, I don't know if you guys ever seen one of those. I'm sure you have them all over your neighborhood. Most telephone poles are creosote old trees that were dipped and treated. While resin molding is when fibers are wound. Okay, so they're wound, and as they go through a process or a tube, then the resin is applied, and then you have this strengthened tube. They can do anything from air tanks to telephone poles, and it usually has a bunch of fibers in it. So if you ever get the opportunity, we have one pole like that here at Trask, and if you got really close to it, you could actually see the fibers wound in it. If you ever see something round, we'll have something at the Saturday's meeting. But if you ever see something round, you usually are able to see those wound fibers in that. Next.
What other application can you think of?
You want to let them answer that? Okay, I'm going to turn that back over to Andrea.
So this last slide here, it says, what other application can you think of? So if, does anybody have any idea besides the things we've talked about? Can you think of anything else? I mean, we named a lot.
Bridges?
Yes.
Nobody thinks of anything? Because we named almost everything, huh?
You said bridges. Somebody said bridges.
Bridges.
I said like a Golden Gate Bridge or something like that.
Awesome. And there's actually, if you look in the the book, one of the things you could actually make is a little bridge and make a composite. You form it. We won't have time to do that, unfortunately, but that would be really cool if you had the time to like make a bridge. And but yes, definitely. So that's, thank you. So
But you mentioned the Golden Gate Bridge. Understand the Golden Gate Bridge is made out of.
1 second. Ranger Anthony wants to say something.
I heard Golden Gate Bridge, and I love the Golden Gate Bridge. It's all steel construction, and even the cables were steel and wound well in the construction phase. So there's very little composite. If you're going to think about composite on a bridge, it might be a walkway bridge, a foot bridge, or something that would have the floor down. But when it really comes to suspension bridges or things that bear a lot of load-bearing weight, such as a bridge like the Golden Gate Bridge or the Oakland Bay Bridge, then that's different. They are using a lot of composites, though, in bridges that are, like I mentioned, the pipe, the winding of the pipe. So again, they'll use a composite for the staff or the main pillar, and then they'll send cables off of that. And a lot of that comes in commercial applications as far as aesthetics. They're trying to make something look really nice, exciting. I think the bridge at Summit, there's a bridge there, and there's a lot of composites in that bridge. But most of your structural stuff is steel.
Okay, and when he says the Summit, he means the Summit Vector with scout camp, the high adventure camp over in West Virginia. All right, so for number 4B, because 4A says visit a company, obviously we don't have the ability to do that right now. So you can do A or B. So we're doing B, and you're supposed to find 3 composite-related websites. I have several of them listed on the screen here. You can go ahead and write down some of those, or wait till you get this video. You're supposed to share, discuss what you learn. So from 3 of those, you're going to look them up and share what you learned on 3 of them. Okay? All right, and again, I'm going to send you this presentation, so don't worry about it. So career opportunities, real quick, number 5 in your workbook on page 13, that's what you're doing in person on Saturday. So skip number 5, okay, because we'll be doing that on hand, because you actually get to play with the resins and stuff. Number 6 is your 3 career opportunities. I list several of them on the screen here. You've got a chemist, a chemical engineer, designing those boats, a product designer, a material engineer, production engineer, laminator, believe it or not, a mold fabricator. Okay, those are several careers as a composite material career. So you can choose one of those, write 3 of them down, choose one, and then look up the education, training, and experience. And tell me why you chose that one. Okay, so you can show me that stuff on Saturday, or you can email it to me. It's up to you. You can always fill this workbook in online. They have PDF fillable ones online through that link that I sent your parents, and you can fill it in and email it too. All right, so other than that, so there's an announcement. Like he said, the credits, MC Gill is the corporation that's actually over in El Monte that always asks us to put these on this class. Okay, so for Saturday, like Ranger Anthony said, you will be working with these materials. And there's resin, there's all kinds of composite stuff we're going to be working with. Definitely do not want to wear your Class A uniform. Okay, no Class A, because I don't want you to mess it up. Your parents would have a fit. I would, if my kid did it. You want to wear, if you have an activity uniform shirt, you're welcome to wear that. But even wearing that, you should always bring like an old oversized shirt, like a really big shirt that you can put on over your clothes. That's really old, it can get messed up. Okay, just in case you spill some of it on you, this stuff is not going to come out. No matter what you do to the fabric, it's not going to come out, okay? It will ruin the clothes, okay? So old clothes, for sure, at least in the top. We will give you the gloves. Like Anthony said, we'll give you the mask. You'll wear your face covering, obviously, that you wear all the time now. And then you can put this other mask on top of it. You will have goggles, wrap around goggles to protect your eyes. You're welcome to wear a hat if you want to. It's not a big deal. If you have long hair, I think Jayla might. If you have long hair, please, wear a ponytail to keep it out of your face, just in case you put your head down and get it in there. Other than that, does anybody have any questions about Saturday? We're good? All right. So, again, I'm going to upload this recording, and then I'll email the link to your parents. You guys can get some of the information to fill in anything that you didn't have already or you need to finish, and then you can email it back or you can bring it with you on Saturday, okay? So if we don't have any other questions, I'm finished. We're good? All right. So Saturday, your class is at 9 a.m. So arrive by 8:45. I emailed the information to your parents. When you get to Firestone, it does take you about 15 minutes from the time you get off the freeway to the time you get to the class. Because you're gonna have, if you've never been to Firestone, it's a very, very long road. Not like our road, but it's a long road. It looks like it's going nowhere. It's really long, so it's gonna, and you have to go through a guide. A guide is going to open the gate for you, okay? So when you get there, the guard, tell the guard you're there for composite material, merit badge. He'll let you in, and just keep driving until you see somebody, which is probably myself or Ranger Anthony, and we'll direct you on where to go, okay? And like he said, you won't be there. I had the class set for 2 hours, but you probably won't have to be there for 2 hours, okay? Any questions at all? We're good? All right. I'll see you Saturday. Have a good evening.